Good morning, everyone. Welcome to the first talk at Streaming Media West, which is the ever scintillating and ever controversial subject of HEVC. We've been doing this update, I want to say, for about 3 years now. Ironically enough, it started out as, we have this great new standard and everyone thinks we're going to implement it tomorrow morning, but the ecosystem needs to fall in place. And so it's going to be 2015, 2016 by the time it deploys. And so here we are in 2016, and I find myself on the opposite side of the spectrum, talking everyone off the ledge that HEVC is already dead and dying. So it's been interesting to see how this talk progresses. But here we are. So why does our opinion matter? Or why do you really want to listen to what we're saying here? I'm part of the digital media research team at Frost & Sullivan. We look at a wide variety of stakeholders in the digital media ecosystem, from silicon, encoders, transcoders, distribution, CE devices, middleware, monetization, content protection. And so when we make predictions here or when we provide landscapes here, this is a fairly well thought out, fairly well researched perspective, and it tends not to shift from month to month. We've been fairly steady in our predictions. Specifically at Frost & Sullivan, I cover encoding, transcoding in terms of video technologies as well as products. And I also look at CE devices and content protection. So again, it's that end-to-end perspective and conversations with a number of different stakeholders, the suppliers, the vendors, and the consumers of the technology. All right, so quick run through of what we're going to talk about today. First of all, the why HEVC. We tend to see a lot of conversations that say, well, HEVC is going to be adopted in tandem with 4K. And that's absolutely correct. 4K is a driver, particularly from the devices standpoint. But HEVC is being used in a number of broadcast applications, in a number of enterprise applications. And that has to do with the 3 Rs, and we'll get to that. It's been a very good year for HEVC. The royalty issues are starting to get resolved. The product ecosystems are starting to look very good. Certainly, there are challenges. We'll go into those as well. And the clock is absolutely ticking, especially in terms of enterprise applications and in terms of the non-premium content types of applications. So we'll get into that. We have a somewhat interesting number in terms of the gap between HEVC-capable devices, those where the processor already supports high-end HEVC decoding in battery-efficient manner, and HEVC-enabled devices, which is where that functionality has actually been flipped on. So again, the ecosystem is a lot stronger than one would think on the surface. It's not a technological problem anymore. It's a business problem, and we'll get into some of those aspects towards the end. This is meant to be an interactive conversation. We have in the past had fairly scintillating debates on the floor. So please interrupt me at any point of time. This is meant as a forum. This is not death by PowerPoint. And also, I have a tendency to speak very fast, especially when I get excited about a subject. So if I'm starting to get incoherent and I'm just rattling on and on and on, somebody wave me down and tell me to slow down. All right, so with those caveats, there are, in the lines of reading, writing, and arithmetic, there is revenue, resolution, and throughput. This is what drives the need for HEVC. Up until last year, AVC was practically ubiquitous, extremely sensible in terms of your main workhorse codec. Now, you're starting to see the limits of how much you can accelerate AVC, even if you throw an immense amount of CPU at it. So with equivalent CPU thrown at AVC and thrown at HEVC, the encoding tools are getting sophisticated enough that you are starting to see significant improvements in HEVC. Netflix put out a very extensive study. This was for video on demand content. It's accessible through the Streaming Media blog, among other links, or just email me, I can send you the link. They're starting to see the performance improvements approach the theoretical expectations. Now, that is for VOD content. If you look at live, the densities are not there yet. The efficiencies are not there yet. The latencies are not there yet. But it's a curve that continues to progress every couple of months or so. So that ecosystem is looking really good. in that sense, 4K is becoming more feasible. But again, the value proposition of HEVC goes far beyond 4K. It actually goes to HD and HDR and virtual reality as well. If you look at the table there, this is from Akamai. A population of about 1 billion people in India, a huge market for TV. But the average streaming rates are a fraction of what you would see in a more advanced economy. So if you marry that with the fact that HD and 4K TVs are being sold extremely rapidly in these kinds of markets, and there is tremendous untapped OTT and TVE potential there, services want to get to semi-urban cities in India, to the vast reaches of the African subcontinent, to Latin America, to Central and Eastern Europe. You don't have reliable broadband, and in many cases, broadband is subject to data caps, so bandwidth matters even more. HEVC has the ability to double, triple, quadruple your accessible audience for HD programming, for HD plus HDR programming, for satellite services, for digital transmission, digital terrestrial transmission services. Your OpEx can drop dramatically because your expenses are directly proportional to the power you consume. The power is directly proportional to your bandwidth for all practical purposes. And so there are revenue and throughput benefits to be gained for HD and HDR as much as for 4K. And then in the smart TV segment, in the streaming media devices segment, we'll get to the details in a bit, you can actually charge much more or you are less susceptible to price wars if you have 4K, HEVC, and HDR support in tandem. So HDR is not coming to AVC, it stays with HEVC. There are some variants of VP9 that do support HDR, but it's a much more limited use case. And so again, HEVC is a powerhouse codec. It has very compelling applications. We just have some business challenges that we need to get through. So these are the key developments in 2016. We have DTT with HEVC that's mandated in Germany, for all practical purposes mandated in Italy. The United Kingdom, in its new release of the Freeview Play, mandates HEVC now. Ultra HD with Blu-ray is already based on HEVC. You're starting to see, if you look at it from the crossing the chasm paradigm, very strong beachheads of applications that are rooted in HEVC. We also see a lot of closed-loop command and control applications, a lot of closed-loop contribution applications, where you have a very limited number of encoders and decoders, no tangible revenue to speak of, so the licensing issues are not a problem. You start to see HEVC making very strong inroads there as well. Encoder densities are getting better. And most importantly, the royalty issues, particularly with HEVC Advanced, are starting to get mitigated. So we do now have caps on the royalties. They are high caps, and the minimums are not very low, but still there's progress being made. Ad-supported content, content 12 minutes or less is now exempt from content royalties, so again, big step forward. Not to say that everything's been solved. We still have certain, shall we say, brain-dead provisions in the royalty schedules, but as we continue to see momentum, as there continues to be industry evangelism, we continue to see progress on that front, and that's really important. There has been a movement to try to push for royalty-free HEVC. I think in all practicality, that's not going to happen. This is a commercial codec. There are R&D investments. This is not an open source, free to use type of codec. There are others if that's the kind of option you're looking for. But insofar as it needs to be a commercially sensible licensing regime, that's absolutely something we can push for. The other big flip side issue right now is the absolute lack of support, or the predominant lack of support for HEVC in browsers. So Edge includes HEVC, but none of the other browsers do, and HTML5 as of now does not support it. This isn't so much a technological issue as it is, again, a business risk issue. If the licensing issues were to be sorted out, or if we could find a deal similar to what Cisco managed for WebRTC, this is, again, another hurdle that can very easily be overcome because the underlying chipsets and operating systems are all HEVC capable. They're just not HEVC enabled. So there are very few categories of playback devices, this is really the takeaway here, that have switched on their HEVC capabilities in its full and native form. Again, that's not to say that they're not capable, they're just not enabled. So when one person decides to flip the switch and move forward, we expect that there will be a very rapid domino effect in its wake. Nonetheless, this is for OTT. If you look at broadcast in the broader sense of pay TV, one-to-many broadcasts, satellite transmission, satellite backhaul, HEVC is very much being deployed. We have encoders, transcoders, professional decoders, set-top boxes, middleware. All of that is falling into place very, very quickly. So this is a story of progress. It's just a story of somewhat slow progress. This is, again, we've been talking about, if you've been following this talk over the years, we talk a lot about the end-to-end ecosystem. What does HEVC look like from the point of capture and encode all the way to the point of rendering and delivery? For the first year, this year, we've seen 4K contribution encoders work in single slice mode. So very often with 4K contribution, you had 4 HD AVC encoders working in sync with each other. Now we have what are called single slice encoders. So they're taking the entire 4K frame, compressing it in real time, and sending it out. The single slice encoders are still expensive today. The cost is falling, and there are ASIC and hardware versions that are in preparation. So again, by the time we get to NAB, certainly by the time we get to IBC next year, this is going to be a solved problem. We're starting to see lower and lower latency, both for the regular 8-bit compression, but also for the 10-bit compression. So HDR was somewhat late to the game. There was some issues with the standardization there, but HDR encoders are starting to come into silicon as well. So again, another big leap forward on the encode-transcode space. Transcoding, for better or worse, lives in the cloud where computation resources are a lot more abundant and a lot less expensive. So that's moved forward very quickly. And there's been a very welcome development where you now have ABR manifests. ABR adaptive bitrate is, I should have done this. How many folks are techies in the room? Okay, almost everyone. Content service providers? Couple? Okay. So adaptive bitrate ABR manifests are the sort of the table of contents that tell you where to find each of your individual files. We've seen mixed mode manifests where the lower bit rates are AVC streams and the higher end ones are HEVC streams, and you can mix and match those at will. So that's starting to, again, ease the deployment in terms of the transcoding and the distribution of HEVC content. The playback is still where the bottleneck is. Especially insofar as browser-based playback. So if you're playing back in apps, this is not so much of an issue. If you're playing back on smart TVs or the higher-end streaming media devices, this is not so much of an issue. But if you're talking about everyday enterprise applications, if you're talking about user-generated content, that is very much where the bottleneck is today. Again, to emphasize, this is not a technical bottleneck. This is a standard mandate and business justification bottleneck. The technical bottlenecks are on the encoding, transcoding side, but the investments now are strong enough and sustained enough that we'll continue to see that bar move over time. Are there any questions so far? Is anyone in violent disagreement with any of this? Okay. All right, so competition to HEVC is growing. Whether we like it as compression standard purists or not, there is a window that is narrowing towards getting HEVC out of the problem codec mode and into the problem-solving codec mode. So AVC was always a competitor. VP9 was always a competitor. The new versions of VP, or the VP codec, VP10 or whatever version may come after it, the changing profiles are an issue. Proprietary codecs have been making quite a bit of noise, and they will continue to do so. In China, AVS 2.0 is now a mandated standard for the next generation of broadcast. It is required to be built into all smart TVs that are sold in China moving forward, so that's going to be a problem. And then on the horizon, of course, is AV1, which is the Association for Open Media. It's not OMA, it's AOM or some other scramble of the acronym. But this is not so much a new codec as it is symptomatic of a fundamental shift of power away from the traditional IP-centric, R&D-centric video compression technology developers to the IT-centric, infrastructure-centric, cloud-centric technology vendors. So you're moving away from the Dolbys and the Technicolors and the Matsushitas and the Panasonics of the world to the Amazons and the Googles and the Ciscos of the world. That shift is more of a competitive issue in the long term. And again, it boils down to this notion of royalties and to what extent royalty can be used to hijack an industry. So I'll breeze through this somewhat quickly. These are your video compression choices as of today. The AV1 Harvey balls are somewhat hypothetical in that the standard hasn't actually been released, but based on conversations that we've had with those who are active in the standard, this is where we think the cards will fall for the first generation. So AVC, as you can see, if you get rid of the 4K HDR consideration, it is still your go-to codec. Nothing changes there. It's the cheapest, fastest, densest, most reliable, most trusted, most interoperable codec that you have available. So to the extent that you can afford to use AVC and it is not hindering your audience reach or your resolution targets, AVC is the way to go. Optimize your codecs, check your presets, renegotiate your CDN pricing, transfer to IP-enabled virtualized workflows, but you don't have to replace AVC if it's working for you. If you're starting to move towards HDR, towards 4K, towards virtual reality, if you want to reach audiences that don't have AVC-friendly bandwidths, then today you can choose between HEVC and VP9. There are pros and cons. So VP9 is not mandated by the broadcast standards, and none of the standards insofar as pay TV or HBB TV, the DVB standards, none of those are VP9 centric. There is also a very limited set of encoding and transcoding libraries. You typically don't tend to have quality of service analytics available for VP9. It's very much an enterprise user-generated content, sort of large-scale B2C distribution outside of the premium content type of codec. That can change, and it will be more likely to change the longer that this HEVC stalemate drags on. But at this point of time, if you're looking at a premium TV service, at a full-fledged OTT service, if you're going to need DRM, if you will need analytics, if you need measurements, if you need interoperability with a number of different apps and browsers, then HEVC and AVC are still better bets than VP9 for now and for the long term. With AV1, some of that equation may start to change. Any questions here? All right, so what are some of the applications for HEVC, right? We tend to see a lot of chatter about, again, 4K broadcast, but even if you look at something as simple as surveillance, with the new licensing terms being released for surveillance, it's a lot easier now to check what your costs will be. Surveillance also depends very heavily on high dynamic range, HDR, because the lighting conditions in surveillance tend to be very limited. So it's a beautiful application for HEVC. We do have several silicon chips that are already supporting HEVC encoding. We have some camera models that are starting to support HEVC. Not so much uptake yet because the devices are fairly new, but we expect that to grow very, very quickly. And then if you marry that with things like smart city projections and traffic cams and body cams for law enforcement and all these different trends that are driving surveillance, this starts to look like a very, very solid market for HEVC when 2 to 3 years out. Virtual reality, Adobe already supports HEVC as an export format along with VP9 and AVC, I think, for the virtual reality videos. We expect that to continue to grow. VR is, in effect, the most immediate application of 4K. If you want to do an HD rendering of a VR experience, your source video is going to be 4K in size. So your end-to-end workflow will be a 4K workflow for all practical purposes. And HEVC is uniquely suited to that. It is hard right now to do a just-in-time transcoding type of workflow for VR with HEVC because of the latency and the processing issues. But if you're going to download it and if you're going to play it back on a PC or on an Xbox, it works really well. Nintendo and PlayStation don't have HEVC support as of this generation of devices. That may change. We don't know yet. But for several use cases, at least, it's there. So the infrastructure gap is still high for surveillance and VR. These are the newer applications, but the potential ROI is quite strong. That's what you see on the y-axis. The x-axis is the relative infrastructure gap. For contribution for HD and Ultra HD broadcast for cloud DVR, we're starting to see the gaps narrow increasingly. Set-top boxes are starting to support HEVC. The encoders and transcoders are already there. And then if you look at mobile OTT, that's another one in the context of data caps, in the context of limited bandwidth, and in the context of growing video consumption. This has the ability to make a huge difference. We tend to see the Cisco number quite a bit. 82% of all internet traffic will be video. There's a more important number that underlies that internet traffic itself is going to triple or quadruple between now and 2020. So it's not just that video is going from less than 60% to over 80%, it's that the traffic volume as a base number is going up by 3 to 4x as well. There are markets beyond media and entertainment where HEVC adds value. I was talking to a gentleman from Carnegie Mellon this morning about how there's a lack of physical space in universities. And it's not so much that you need to shrink the video, it's that you can't do video at all to the scale that you need to do it and the capacity you need to do it if you can't shrink these numbers down. So when you look at healthcare, for telehealth, for example, if you want to improve resolution, if you want to increase frames per second, any kind of resolution increase needs a new kind of codec. Surveillance, hospitality, defense, when you're talking about real-time video-based command and control, several vendors who are out there with hardware ASIC-based encoders and decoders that are leveraging HEVC to a very strong advantage. Essentially, you can get 4K quality video, or you can get twice or thrice the frame rate for the same satellite uplink and downlink bandwidth, which you can't really change in a command and control situation. In gaming, esports, virtual reality, online immersive gaming, any place where you want to increase frames per second, even if you don't want to increase the frame resolution, is a very strong candidate for adopting HEVC. Communication, webinars, video conferencing, virtual presence, these are all strong applications for HEVC. We're already seeing HEVC become table stakes in the closed loop enterprise type of systems where the encoders and decoders are not that large in number, and the operating costs are very, very important to an enterprise. When we talk about things like FaceTime and Skype, that's a slightly different equation, but in enterprise video conferencing, HEVC is already making a huge difference. So again, to reiterate, the higher the need for resolution, the more you need frame rate increases, the stronger the value proposition that HEVC can give you. Competitors here are AVC, which is the status quo, JPEG 2000, especially for things like archive and post-production, the early stages of the workflows. And then VP9 and 10, of course, continues to be a consideration. So here's what the royalty snafu really looks like. When we talk to different vendors and different users across the ecosystem, the encoder vendors have a very optimistic view of HEVC. They're selling more encoders, they're selling more decoders, trials are up, deployments are up, channels are up, everything looks great. And then you talk to the CE device vendors, and they continue to say that HEVC just doesn't have momentum. It's not getting there. Nothing's moving. It's like watching stones grow. So what's the disconnect here? If you look at browsers, again, other than Edge, you don't have HEVC support. If you look at computers other than Windows 10, which still has a relatively small market share, you don't have HEVC. That will grow over time. Set-top boxes, the higher-end devices do support HEVC. The lower-end boxes, especially in cable, are still MPEG-2. So there's a transition process that will have to happen, and it will take several years. The gaming consoles, the new Xbox has HEVC support. PlayStation and Nintendo, as of now, do not. We don't, at least I don't have public insight into whether that will change. I expect in another year or two, they will have to move the ball forward there. With phones and tablets, it's more of an enablement issue. Apple, of course, has very visibly stepped back from HEVC. Some of the others are more aggressive about it. Android, as an operating system, has HEVC support built in, but it may or may not be turned on in the final device, again, subject to royalty considerations. Where you do have a tremendous movement on HEVC, particularly in the second half of 2016, we expect this to get stronger in the holiday season moving into CES next year, is smart TVs and media streaming devices. And if you were here for the Roku keynote, you can correlate that to the numbers. Online TV consumption is growing fastest on smart TVs and media streaming devices. And pay TV and OTT operators, we more or less consider Netflix now to be a pay TV operator in its own right. So with that definition, all pay TV operators are starting to look to 4K to create differentiation, to increase ARPUs, to increase customer loyalty, particularly in major markets. And so it's kind of logical that smart TVs and media streaming devices are where you see the fastest deployment, not just in terms of capable, but in terms of enabled for HEVC. However, if you look at that pie chart on the top left, they're a very small sliver of the total universe of CE devices. So even though you have these individual pockets that are growing very fast, if you were looking at the larger picture, which is what the consumers and the player developers tend to do, that's where you're still seeing rocks grow. It's very, very slow. Now, if you look at the processors, whether it's the processors for the tablets or the smartphones or the PCs or the set-top boxes, they all have HEVC built in. And a good percentage have HEVC 10-bit built in. So that's your gap. I took the number of devices that were shipped in 2016, HEVC capable versus HEVC enabled. I extrapolated that to the total number of deployed devices that had hidden or dormant HEVC capability. And I multiplied it by a very conservative royalty rate, assuming that more or less every vendor hit their cap at some point. You're still talking about around $3 billion. Just in terms of royalty, this is not device revenues, this is royalties of 80 cents a device on average that are waiting to be turned on. So in a way, there is a penalty, and this is my industry evangelism for let's just break the licensing logjam already. The longer you wait, the more all these devices start to get clubbed, and when you flip the switch on in a given year, they're all going to be subject to the cap for that year, because you're de facto shipping HEVC devices in a given year. So there's $3 billion of royalty revenue just sitting there. We really need to start to move this forward. And to the extent that industry evangelism can help, that's an argument to be made for it. Any questions here? All right, so these are the drivers and restraints for HEVC. Again, this is a slide we tend to refresh every year. Standard mandates, as you can see, and we talked about this in the very first slide, are driving HEVC forward in terms of DTT Ultra, HD Blu-rays, the Freeview Play type of standards, the OTTs, the apps that are already providing HEVC as part of their SDK, particularly in the 4K and the HDR context. Where you have cost-efficient or bandwidth-limited HD, if you want to reach more users, if you want to increase your ARPU, HEVC can add value today. If you have a closed loop B2B application, the royalty issues are really not going to be a needle mover for you at all. So that's a great place to deploy HEVC. But the licensing uncertainty is absolutely an issue. And the ability to continue to get gains out of AVC, if you haven't optimized your workflows already, is absolutely a reason to wait. And sort of see how this thing plays out. Industry evangelism is helping, so we are assuming that within 2 years, so hopefully ahead of the FIFA World Cup in 2018, this logjam will be broken, and we will see a bulk switch on of HEVC decoders, and that will start to really move the needle. Now, if that doesn't happen, you're going to start to see competing codecs really step in the 2020 timeframe. So the next 2 to 3 years are fairly critical in terms of where this roadmap goes. We still believe that HEVC has a very strong value proposition and that common sense will eventually prevail. But in terms of falling back to AVC where you can and looking forward towards AV1 when you have to, the next 2 to 3 years are where a lot of these things will shake out.
Do you think it's just the fact that it's the royalty issue, or what is really holding people back from switching on and going to HEVC if it's such a wide use? I mean, it's kind of a...
So part of it is also the revenue potential. So if you look at 4K as one example, you still have the same old issues that 4K always had. It's not accessible by a large percentage of broadband users today. The set-top box process deployment is slow. So satellite vendors are very aggressive in terms of rolling out new boxes. If you're a cable vendor, you're still stuck with MPEG-2 legacy boxes. So there is some of that in play as well. But and then insofar as the broadcast standards, right? So ATSC 3.0 just did a trial in the US. I think it was Ohio or Oklahoma. A Fox affiliate did their first ATSC 3.0 broadcast, but that's going to happen slowly. So one inflection is the 2018 World Cup for soccer. The next inflection is the 2020 Summer Olympics. You tend to need those big events to really move the needle forward. We missed the Olympics this year. So ideally speaking, you would have seen that big jump in 2016. It didn't happen now. So the next opportunity is 2018, and then pretty much the last one is 2020. But there's also, again, this notion of if the royalty issue were to be resolved tomorrow, you've got that set of, I think, like 4 billion devices that you could just switch on. And if FaceTime moved to HEVC, which they could, because they did and they moved back, and Skype and Link moved to HEVC, then you've got a market just sitting there. And the high-end Rokus already support HEVC, so all those channels that we talked about could move. Apple TV, the chipset is capable of decoding HEVC, so again, you could just move that. It takes some time to retranscode libraries. It takes some time to get workflows in place, but the primitives are all there. So it's not really a technology challenge. It's is it profitable, and how profitable is it to roll out the new type of service? And then do you have the decoder footprint available? Does that answer your question? Any other questions? Yeah.
So are consumers demanding? I mean, you said that the hold-up on HEVC is based on 4K, just UHD hasn't moved yet.
One of the hold-ups, yes.
So are consumers, in your research, are consumers like demanding it? You've got this large base of TV devices that are capable of displaying UHD. Yet, so are consumers asking for it? Is it, or have they just said, it will come when it comes?
No, it's a good question. So the question is, I'll repeat this for the benefit of our live streaming audience, are consumers demanding 4K? And given that we've seen a growing footprint of 4K TVs, that we're seeing 4K-enabled streaming devices, 4K-enabled other consumer devices, is there consumer demand for 4K? Yes, absolutely there is. And it comes in two forms. So consumers are willing to pay slightly more for 4K services, but they stay more engaged, and they watch longer, and they watch more if the video is more beautiful. The other problem with 4K is there's still somewhat of a dearth of source material that is natively shot in 4K. And if you're taking SD and just stretching it through pixel replication to 4K, you're doing more harm than good. So there's a little bit of the ecosystem that kind of needs to step into place, but for 4K content that is beautifully produced and that is delivered at reasonable price points, there is very, very strong engagement that's being reported with 4K content. There are studies that show that if you have HD HDR or HD 120 frames per second, particularly for things like sports, it shows better user characteristics than, let's say, 4K at 15 frames per second. So there's a little bit of dependence on how good the source is and how good the alternative experiences are. But in general, 4K TV, 4K film is exceedingly popular.
So, I mean, does that imply that HDR is really the killer then rather than the 4K resolution? I always distinguish, as you well know, between
Yes.
4K and actual UHD.
Yes. Yes. So the question is, is there a differentiation between increase in pixel resolution from HD to 4K and increase in color depth resolution from 8-bit to 10-bit and then wide color gamut and high dynamic range? Yes, absolutely. The two work somewhat in correlation in that if you have 4K HDR, it looks better than HD HDR. But if you have basic 8-bit 4K content at 15 frames per second, let's say, and if you have HD content with HDR at 60 frames per second, it is very likely that the HD content will look better than the 4K content. And that's why we are really trying to make this point that HEVC has benefits and applications independent of 4K. If you wanted to do HDR, you can't do it with AVC today. And you could do it with VP9, but you kind of have to jump through hoops, and the standard ecosystem is just not as reliable as the HEVC ecosystem is. Now that said, HEVC, HDR encoders are also somewhat slim pickings on the ground because the HDR standards were just finalized, and it is quite difficult when the rubber meets the road to get the right transfer functions for the HDR coefficients, especially if you're shooting live. If it's movie or film content, it's somewhat easier. But despite all of that, the HDR content does tend to create a better user experience than 8-bit content. Is there a question in the back? Any other questions? All right, so in terms of closing thoughts, as always, please pick your battles. Certainly the codec choice is important. If HEVC is not in your labs, bring it in today. If you're not looking at ways in which you can use HDR and improved HD and 4K in your business model, start looking at it now. Create a good sense of where is your expenditure, where are your growth bottlenecks, and where is compression the single option that you have to help solve the logjam. If you're looking at churn management, which is probably the most important issue for all types of pay TV providers today, whether you're traditional pay TV providers or new media pay TV providers, managing churn in terms of beautiful content, but also in terms of user interface. Those two go hand in hand. If you have the prettiest content on the planet, but nobody can find it, and it's not discoverable, and it's not a personalized search interface, it doesn't matter. And so there are many different facets that you always have to keep in mind as you build and modernize a business. The codec is one aspect of it. So even as you're looking at new codecs, also look at making sure you're getting the best performance out of your AVC encoders today. If the last time you bought an AVC encoder was 4 years ago, it's time to replace that AVC encoder first. And most professional encoders now are software-based, so you can buy them for AVC and upgrade them to HEVC later without losing your investment in the underlying hardware. So there's really no excuse for making sure that you have the absolute most state-of-the-art AVC encoder and transcoder that you can find today. You are going to have to look at migrating to Dash, either in the context of HTML5 or in the context of apps or in terms of a combination of the two, especially with Flash being discontinued. That timeline has been accelerated to a greater degree than I think many of us had anticipated. And then, again, targeted advertising driven by analytics, that is where the revenue is going to come. That is where the differentiation is going to come. So even as much as the codec and the move to 4K are important, there are many other battles you need to be fighting in the short term. With that, these are the key takeaways. So HEVC has had a very good year, both in terms of applications and in terms of starting to solve the licensing issues that were creating a lot of the logjam in 2015. Certainly there are still issues to be solved, but we at least remain optimistic that by 2018 we should start to see that big surge in uptake. We were originally predicting that for 2016. That window, of course, we have missed. But this is not to say that HEVC is dead, not by a long shot. You do have an issue with bandwidth crunches. You do have an issue with data caps. Global growth of OTT services, TVE services is an absolute necessity. If you embrace the paradigm that we're moving away from the broadcast sense of TV towards a pervasive unicast view of the world, every byte that you can save is important. Every disk that you can save is important. And the extent to which you can increase resolution, whether it's frame rate or color depth or pixel resolution, starts to drive audiences back to where you want them to be. So with the analogy of a self goal, because my kids are 8 and 10, and that happens with annoying frequency every Saturday morning. Someone in some game will kick the ball into their own goal. That's kind of what it is with HEVC today. The battle is really to be lost or won on the basis of non-technical issues, primarily business justifications. But nonetheless, there are plenty of applications where, uncertainty or not, HEVC makes a lot of sense today and is going to continue to make sense for its entire intended lifetime. So that's, thank you. I do want to acknowledge the many, many vendors who speak with us. It's easy for me to get up here and pretend like I know everything about everything. I don't. I sound smart because of all the input that we get from many different stakeholders. These are just some of them. We're accessible, sorry?
Oh, just have a question. You referred to the
Yes and no. So, 20 cents a decoder or 80 cents a decoder is one issue, but I think it's also the paradigm, right? So when HEVC Advance first came out, they had uncapped royalties. And they wanted percentage of revenues from all HEVC content, which would have included ad-supported content, which could have included if Amazon had a product video compressed in HEVC. You could argue that a percentage of the retail sale price was payable to the royalty pool. And so there was just a lot of uncertainty in terms of what was in scope and how it was being administered. If you look at the terms today, the software terms are still not clear. So it's not clear, for example, if you were a browser and you were using the HEVC codec that was built into the underlying operating system or in the underlying hardware, are you a royalty-bearing software unit or not? When those kinds of things get clarified, you tend to see big jumps forward. There's another provision, for example, that says every time you rent an HEVC piece of content, you have to pay 2.5 cents. How do you track rentals if you're a small Romanian outfit, for example? So there's just, it's not so much how much money you're paying per unit, but how many different ways are you being metered, and which ones of those are even feasible ways of metering.
I see. So it's just not keeping up with the data.
It's not. And if you ask a CFO to say, you must give me monthly subscription numbers every month for your service, many of them are privately held and never release those numbers. So if you don't have a reasonable cap and you don't have a reasonable minimum, you're forcing them to report numbers that they may have no interest in reporting. And so there's a whole bunch of issues that have nothing to do with the price and have everything to do with the structure. And in that sense, I mean, I'm an analyst, I'm not supposed to play favorites, but I think MPEG-LA, with the experience of having gone through the original MPEG-4 video and the new AVC and really having seen how the industry works and how it's moved towards software and OTT, I think they got it right, both in terms of price and in terms of structure. Whereas HEVC Advance, again, I may be putting words in people's mouth. I think they still think the world is as the way it was with MPEG-2, and we've come a long way. We've come a very long way since then.
No, that makes sense.
A lot of HEVCs struggling to take off. We know now there's a new initiative under the auspices of Mexico IT, which actually come up with a successor to HEVC, which their timeline is kind of overlaps with AV1, although they work a little more aggressive.
Yeah.
They're targeting compression efficiency of 50% by the year 2020 and so on. Have you had a chance to talk to any of these guys? What is the assessment of their
The assessment is, again, we had that slide, and let me see if I can find it here. So these are the competitors we know about over time. The longer that HEVC is an unfilled void, the more likely that you will have very intelligent engineers coming together and doing their own thing. So, a lot of the open source video codec projects today came out of the void of MPEG-4 Part 2 originally. And, thankfully that problem was solved and one ring came together to bind them all. If that doesn't happen for HEVC, yes, there's a shrinking window in which it can establish the widest possible range of applications. Now, that's not to say that it will not be the future of broadcast. It is going to be the future of broadcast, barring something absolutely insane happening. It is the future of broadcast, HEVC. But if you look at the broader OTT ecosystem, if you look at media and entertainment as well as enterprise, if you look at the complete gamut of video-centric applications, which is pretty much any kind of business or consumer interaction that you can imagine today, that's where there is very much space for other alternatives to come in and take HEVC's territory. And as an industry overall, the more fragmentation you have in codecs, the harder it is to move forward. A lot of these surges we're seeing in OTT uptake, in monetization in devices, and in just video-centric processing, my belief is it comes from the fact that everything is AVC. So you build it once and it's available for everybody to use. If you have one codec for this application, one for that, we go back to the days of Rio video and Windows Media Video and Flash Video and Sorensen Video. And it's very hard to start to break those silos once they crop up. It's hard enough today for folks to deal with HLS, HDS, and Dash. Imagine if we have to go back, throw away all the work we did with encrypted media extensions and CMAF and WAVE and say, okay guys, not only do we not know what we're doing with the streaming, we don't even know what we're doing with the video, and therefore we don't know what we're doing with the audio, and we don't know if we'll have a protected hardware path or not, and now I need to have watermarking implementations for 5 different video codecs. That ecosystem breaks down very quickly. So what you're saying in terms of, there's a possibility of new codecs cropping up, absolutely, we're engineers. If the management can deliver a sane solution, we create them, that's what we do. But the implications on the industry are very, very real. And so there is this shortening window where, as a community, I think we really need to get our act together and say, okay, we're either going to change the mindset or we're going to find ways to create one-on-one deals, or someone needs to create a WebRTC equivalent for HEVC, whatever it is. Unless that happens, and it happens in the next 2 years, a lot of the forecasts are going to start to look a little wonky. Again, my belief is I think that's going to happen because you do have these very strong beachheads of broadcast applications. So once smart TVs have it, once streaming media devices have it, and once you realize, again, going back to the keynote was an excellent example of that, that the engagement with TV and OTT is getting stronger on those platforms. It's going to create a drag back. The question is just for what breadth of applications, for every single one that we have here, or just for a few of them. Does that answer your question? Any other questions?
Can you just talk about what ATSC's position is on the emerging standard and what codec they will adopt as part of their flow?
One more time, sorry. So I'm not the world's best expert on ATSC 3.0. I will defer to those who know more than me. I know that HEVC is part of the ATSC 3.0 decoder specification. So I don't know if other decoders are also part of that spec, but if you have an ATSC 3.0 decoder, you do have to have HEVC. That's what I've been told. But they don't really have a full-fledged timeline or a strong mandate yet, and I think there is some stuff that's still under flux, so I don't know.
Can you comment specifically on the fact that since it's a broadcast industry standard, the preference has been to only include those standards that have a spec and not necessarily open source? Will that
Correct.
affect some of the other codecs that are in there that are
No.
just open source?
No, I don't, at least based on what I have seen so far. So the question is, do we expect that ATSC may embrace the non-traditional codecs, if we can call them that? And nothing I've seen so far would indicate that. The thing is that scale of high SLA, high CapEx deployment, there is a interoperability framework and a testing framework and a mindset that has to operate. And that is not the Amazon, Google, Cisco. Well, Cisco is kind of both ways, but it's not the Amazon, Google mindset. It is the Ericsson, Alcatel, Lucent, Harris, Aris mindset. And that doesn't gel very well with open source codecs, at least not as of now. If they were to set up an interoperability forum, if they were to set up live trials, and if they could get Gates Air and a bunch of other people together, Roden Schwartz, I don't know, Grass Valley, Belden, and prove it, maybe, but that's a whole other ballgame. It's not just sticking stuff in a cloud and creating a software player. That's my perspective. Any last questions, thoughts? All right, well, thank you for being a wonderful audience, as always. If you have any other questions, we're easy to find. Email, call, text, send us LinkedIn messages. We do these talks every 6 months, so if there's anything you'd like to see in the next one, let me know as well. Thank you so much for your time.